Hello everyone. In this video we are going to learn about liquid fuels, and in previous videos we have discussed the differences between solid, liquid and gaseous fuels, and relatively liquid fuels are possessing so many advantages over solid fuels like low ignition temperature, low pollution and high calorific value, etc. And we have one more disadvantages also in case of liquid fuels, because as ignition temperature is low, so it can catch some fire accidents, and that combustion is not controlled. Then, so coming to this liquid fuels, so we have discussed the classification: natural liquid fuels and then artificial liquid fuels, or primary liquid fuels and secondary liquid fuels. Then coming to the primary liquid fuel, so the best example is petroleum or crude oil. So this is primary liquid fuel from which so many fractions will be extracted by a process called as fractional distillation. So here some of the fractions which are extracted from the petroleum are petrol, diesel, kerosene, naphtha, asphalt, etc. based on their boiling points. Then, so if you look into the composition of petroleum, so maximum percentage is carbon, so which ranges from 79.5 to 87.1% of carbon, and next hydrogen 11.5 to 14.8%, sulfur 0.1% in a little traces, and coming to the nitrogen and oxygen, so from 0.1 to 0.5% in the overall composition. Then coming to the classification of petroleum, so petroleum is actually a primary fuel, primary liquid fuel from which secondary fuels will be extracted or fractionally distillated. Coming to the classification, so petroleum are classified into three types. One is paraffinic based, asphaltic base and mixed base. Based on the composition of petroleum, these are classified into three types. Coming to the paraffinic base, it contains saturated hydrocarbons ranging from C1 to C35. Then coming to asphaltic base, the composition of asphaltic base contains cycloparaffins, naphthalines and of course aromatics, whereas mixed base contain both paraffins as well as asphaltic composition. So based on hydrocarbons present, they are classified into three types: paraffinic base, asphaltic base and mixed base. Paraffins contain saturated hydrocarbons, asphaltic base contains cycloparaffins, naphthalines and aromatics. Mixed base contains mixture of these two, paraffinic base and asphaltic base. Then coming to the refining of crude oil or refining of petroleum oil. So here refining can be defined as the process by which petroleum is made free from impurities and divided into different fractions and further treating them to get superior properties. So this process is called as what? So first we have to extract petroleum, and after extraction of petroleum you have to remove all the impurities present in it, and after removal of impurities you have to divide all these fractions by a process called as fractional distillation, then further treating that fractionally distillated fractions for the superior properties. So this all together we are calling it as refining of crude oil or refining of petroleum oil. So this refining includes some different stages. Coming to step 1 or stage 1. So during extraction process from petroleum wells, so petroleum will mix with the brine water which forms as an emulsion type. That means petroleum will get mixed with the brine water or salt water from oceans or from oil wells, so it forms as an emulsion form. So you have to remove this emulsion type, we have to separate this brine water from petroleum by a process called as Cartel's process. In this Cartel's process, the brine emulsion form of petroleum and then brine water is passed through highly charged electrodes by which brine solution and petroleum oil will be separated into different chambers. So separation of brine water from petroleum oil is called as Cartel's process with the help of highly charged electrodes. Then after removal of water, it might contain some harmful sulfur components. So this sulfur components will be removed with the treatment of copper oxide. When we treat petroleum with the copper oxide, the sulfur component present in petroleum oil will be getting converted into copper sulfide, which can be separated by filtration process. So this is purification process. The first two steps are nothing but purification process. Step 1, removal of water by Cottrell process. Step 2, removal of sulfur by treating with copper oxide. Then coming to fractional distillation. So fractional distillation is nothing but separation or distillation of different fractions based on their boiling points. So in this fractional distillation, the crude oil is heated about 400 degrees centigrade in an iron retort, or also called as fractional distillation tower. So this fractional distillation tower contains a cylindrical tower which is containing horizontal stainless steel trays. So I look into this picture, which explains the arrangement of fractional distillation tower. So here this fractional distillation tower contains some trays, and of course it is allotted with the chimneys also. So from the bottom, crude oil is supplied where the temperature is higher or more than 400 degrees centigrade. With these high temperatures, all the fractions of crude oil will get evaporated, and all these vapors will move upwards. When these vapors are moving upwards, they move through this chimneys. These vapors move up through the chimneys, and at different boiling points, trays are arranged. Stainless steel trays are arranged. While moving upwards, these vapors will hit the cap placed on the chimney and condense back to liquid form. And then these liquid fractions are collected in trays from which the fractions will be separated. So at different boiling point levels, different fractions will be separated. So if you observe from bottom to top, the temperature is going on decreasing, and that fractions which are having high carbon chain length will possess high boiling point. So these type of high carbon chain length containing fractions which are having high boiling point will be separated from the bottom portion of fractional distillation tower, and lower hydrocarbons which are having less boiling point will move upwards and can be separated by the upper portion of fractional distillation tower. So this is the arrangement of chimneys and trays in the fractional distillation coal. So overall, in this fractional distillation process, different fractions or all the fractions will be separated based on the boiling point at different levels. So these are the fractions which can be separated from fractional distillation tower. So from bottom, crude oil is introduced. The temperature is more than 400 degrees centigrade, and at or more than 400 degrees centigrade or 400 to 600 degrees centigrade, all the fractions will get vaporized except this heavy oil or asphalt, because the boiling point of asphalt or residue is more than 400 degrees centigrade. So they settle as a precipitate or residue at the bottom, and remaining all the fractions will get vaporized and they move upwards. When the vapors are moving upwards, these vapors will hit the chimneys present over these trays and condense back to liquid form. And then this liquid fractions will be collected from different temperature regions. So this is fractional distillation process. So here the first fraction which can be collected from the topmost region will be uncondensed gases which are having less or lower hydrocarbon chain length ranging from C1 to C4. As hydrocarbon chain length is less, so the boiling point is also less. Then in the similar manner, depending on or based on the carbon chain length present in different fractions, they will be separated at different boiling point regions. So in next slide, we will discuss what are the fractions which can be separated at different temperature regions. So the first fraction which can be separated at lower temperature is uncondensed gases. Carbon chain length of uncondensed gases is lesser, that is C3 to C4, and the boiling point range is below 30 degrees centigrade. So these uncondensed gases will be removed from the topmost region or the lowest temperature region because the boiling point is very less. And the application of uncondensed gases, we can convert these uncondensed gases into some domestic fuel for example LPG. And next fraction which can be separated from the fractional distillation tower is petroleum ether, whose carbon chain length may range from C5 to C7 with a boiling point range of 30 to 70 degrees centigrade. And the major application of petroleum ether is it is used as solvent. The next most important fraction is gasoline or petrol. The carbon chain length of gasoline or petrol range from C5 to C9. Boiling point will range from 40 to 120 degrees centigrade. As we all know that use or application of this gasoline or petrol, that is fuel in automobiles. And this is the most important fuel for our purpose, for our transportation purpose. So the calorific value, and it is compared with the remaining fuels, remaining fractions, the calorific value of petrol is very higher, that is 11,250 kilocalories per kg. Then the next fraction after gasoline or petrol is solvent naphtha. Carbon chain length is C9 to C10, and the boiling point may range from 120 to 180 degrees centigrade. So this is also used as industry solvent or lab solvent. The next, kerosene. Carbon chain length of kerosene is C10 to C16. Boiling point may range from 180 degrees to 250 degrees centigrade, and it is also used as domestic fuel or jet engine fuels. The calorific value of kerosene is somewhat lower than petrol, that is 11,000 kilocalories per kg. Then the next fraction, diesel, automobile fuel. The carbon chain length of diesel is also C15 to C16, and the boiling point range of diesel may range from 300 to 350 degrees centigrade, and the application is fuel in automobiles. Calorific value is also almost similar with kerosene, that is 11,000 kilocalorie per kg of calorific value. Then the next important one is heavy oil. Name itself indicates higher hydrocarbons. So heavy oil carbon chain length may range from C18 to C30. Boiling point is around 350 degrees to 400 degrees centigrade. The major application of heavy oil is cracking, by which gasoline or diesel can also be prepared. So cracking is nothing but breaking down the higher hydrocarbons into lower hydrocarbons. So for that cracking process we can use this heavy oil. And we can also make some lubricating oils, and we can prepare some wax, paraffin wax, and some petroleum jelly or vaselines, and we can also prepare greases out of these heavy oil. The last fraction is residue, whose carbon chain length is more than C30, and boiling point is above 400 degrees centigrade, so that it remains as residue and not as vapor. So from the bottom portion residue is collected, and then this residue we can call it as tar or asphalt, which is used for making some roads. So all these are the fractions which can be distillated or which can be separated by using fractional distillation process. So in coming to this refining of petroleum, I just repeat, first one is removal of water by Cartel's process. Second step is removal of sulfur with copper oxide. Third step is fractional distillation column or fractional distillation process, by which all the fractions will be separated from petroleum with the help of their boiling points. So this is refining of petroleum. Then next is cracking of fuel. In previous slide we have discussed that the use of heavy oil is, the major use of heavy oil is cracking process. So cracking is nothing but breaking down higher hydrocarbons into smaller hydrocarbons. So here we can break down higher hydrocarbons and we can make some gasoline or petrol or diesel type of fractions. So higher hydrocarbons can be broken down to produce some petrol. So petrol carbon chain length may range from C5 to C9. So we can obtain different fractions like gasoline or petrol or some other higher hydrocarbons like kerosene or diesel also. So simply cracking is nothing but breaking down higher hydrocarbons into smaller hydrocarbons. Coming to the classification or types of crackings. So cracking is divided into two types. Number one is thermal cracking. Number 2 is catalytical cracking. Thermal cracking with the help of high temperatures. Breaking of higher hydrocarbons into lower hydrocarbons with the help of very high temperature is nothing but thermal cracking. And breaking of higher hydrocarbons into lower hydrocarbons by using any catalyst is nothing but catalytical cracking. And based on the physical state of heavy oil or physical state of raw material taken, thermal cracking is again divided into liquid phase thermal cracking and vapor phase thermal cracking. And in a similar manner, catalytical cracking is also divided into two types. One is fixed bed catalytical cracking, then fluid bed catalytical cracking. So in our syllabus, we are going to discuss about only fluid bed catalytical cracking. So coming to fluid bed catalytical cracking. It is also called as moving bed catalytical cracking. So here the catalyst used is alumina and then aluminum silicates. So this is the catalyst used in catalytical cracking, alumina and aluminum silicates. In both the types of catalytical cracking, the same catalyst can be employed. And here in this fluid bed catalytical cracking, finely divided catalyst is taken in the reactor and preheated heavy oil is passed into the reactor in the form of gas stream, and this catalyst is kept on agitated by the gas streams of heavy oil so that it behaves as a true liquid. So that the mixture behaves as a true liquid. The advantage of this process, advantage of fluidized bed cracking is nothing but you will find higher degree of mixing between catalyst and then heavy oil. So that with this higher degree of mixing between catalyst and heavy oil, cracking process can be done to a greater extent. So this is the pictorial representation of catalytical cracking, fluid bed catalytical cracking. So this is reactor. Yeah, this one is reactor. And in that reactor, catalyst is taken. Catalyst is Al2O3 and AlSiO3. Al2SiO3, alumina and then aluminum silicate. So catalyst is taken in the form of finely powdered catalyst into this reactor, and preheated heavy oil is sent into the reactor, and this preheated heavy oil mixes up with the catalyst taken in the reactor, and this mixing will be done to a higher degree. And the maximum mixing will happen because catalyst is already finely divided, and then this gas stream of heavy oil is sent into the reactor so that the catalyst and then heavy oil will be agitated in the reactor, and so that throughout the reactor will find uniform distribution by which 100% or maximum percentage of cracking can be done. And with this mixing between preheated oil and catalyst, higher hydrocarbon will be converted into lower hydrocarbon. And you will find some special arrangement, chimney type of arrangement here called as cyclone, which allows only the cracked portions and which will not allow uncracked portions, and which will not allow the catalyst parts through it. So the major role of this cyclone is it allows only the cracked vapors but not catalyst and also not uncracked portions. And after cracking, the cracked vapors will be again sent into fractional distillation tower. Cracked portions or cracked vapors will be sent into fractional distillation tower. And previous slides we have discussed the process of fractional distillation process with the help of fractional distillation tower. So the same process will be taking place here, and from which we will get different fractions, mostly gasoline. And if we get any uncracked portions, if we get any heavy oil as it is, the same heavy oil can be used again for next cracking process. So this is the major advantage of fluid bed catalytical cracking. So by taking this fluid bed catalytical cracking, you will find maximum mixing of catalyst and heavy oil, by which greater cracking will happen, higher degree of cracking will happens. Thereby you will get maximum percentage of cracked vapors which are then passed into fractional distillation tower, by which different fractions can be extracted. So the desired fraction for us is gasoline. So we will collect this cracked gasoline from fractional distillation tower, and further it is treated to remove all these unwanted gases. If it is having any unwanted gases, it can be degasified from gasoline. So this is the process of cracking of petrol from heavy oil. And here we have a regenerator. The major role of regenerator is, with the rigorous use of catalyst, with the rigorous cracking process, catalyst will be getting coated with the carbon. And if once the powdered catalyst is coated with the carbon components, it becomes inactive. The inactive catalyst will be sent into regenerator with air pressure, higher air pressure, so that all the carbon which is deposited on catalyst will be converted into carbon dioxide and will be eliminated as flue gas. So the major role of regenerator is to regenerate inactive catalyst process. With the rigorous use of catalyst can become inactive because the carbon component will get deposited on the catalyst, so that it will be sent into regenerator. In this regenerator, all these carbon will be converted into carbon dioxide, and the carbon dioxide will be eliminated in the form of flue gas with the help of cyclone. So this is fluid bed catalytical cracking. So in this video, we have discussed the classification of liquid fuels, composition of liquid fuels, and we have also discussed the refining of petroleum oil, which includes 3 steps: removal of water by Cortell's process, removal of sulfur by treating with copper oxide, and fractional distillation, by which we will get all the fractions according to their boiling points. And the next, we have discussed cracking, types of crackings, thermal cracking and catalytical cracking also we have covered. And in catalytical cracking, we have discussed fluid bed catalytical cracking, which is also called as moving bed catalytical cracking. Thank you.